So today we will discuss about the PN junction. A PN junction is an arrangement made by a close contact of N-type and P-type semiconductor. We can see in the diagram. This is the symbol of PN junction. Moving to the next slide. So we have two important terms, depletion region and potential barrier. What is depletion region? So basically, the depletion region refers to a region where flow of charge carriers are decreased over a given time and finally results in empty mobile charge carriers or full of mobile immobile charge carriers. Whereas the potential barrier in the PN junction diode is the barrier in which the charge requires additional force for crossing the region. Also, we can see in the diagram, this is the depletion region, whereas this is the potential barrier or the barrier potential. In the next slide, the effect of doping concentration on depletion width. So, what is the effect of doping in the width of depletion region? As the doping concentration increases, the depletion width decreases. No effect on barrier potential. We see if we increase the doping, the width of depletion region increases, hence the current increases, but it has no effect in the barrier potential. In the next slide, we have types of biasing. We have two types of biasing in our syllabus, forward bias and reverse bias. The P side of the diode is attached to the higher potential and N side of fixed to the lower potential side of the battery. This is the symbol of Zener diode or simply a diode where this is the P side and this is the N side. We can see in the battery the positive side of battery is connected to the P side, whereas negative side of the battery is connected to the N side. This is the reverse bias. So let's understand what it is. The P side of the diode is attached to the lower potential or the negative potential, and N side of the diode is fixed to the higher potential side or the positive potential side of the battery. So we can see the P side is attached to the negative side of the battery, whereas the N side is attached to the positive side of the battery. Moving to the next slide, forward bias. So this we can see the forward bias. In forward bias, the depletion region decreases, current increases. So this is the diagram. Let's move to the next slide. Yeah, so forward bias. When a diode is connected in forward bias condition, a lower voltage is applied to the N-type material and a higher voltage is applied to the P-type material. If this external voltage becomes greater than the value of the potential barrier, approx 0.7 volts for silicon and 0.3 volts for germanium, the potential barrier opposition will be overcome and current will start to flow. This is because the negative voltage pushes or repels electrons towards the junction, given by them the energy to cross over and combine with the holes being pushed in the opposite direction towards the junction by the positive voltage. Depletion width decreases in forward bias. Resistance also decreases, which implies the current must have increased. Moving to the next slide. Reverse biased. We can see in reverse biased the width of depletion region increases. So this is the circuit diagram of uh, reverse bias. Moving to the next slide. So what is reverse biased? When a diode is connected in a reversed bias condition, a positive voltage is applied to the n-type material and a negative voltage is applied to the p-type material. The positive voltage applied to the n-type material attracts electrons towards the positive electrode and away from the junction, while the holes in the p-type end are also attracted away from the junction towards the negative electrode. The net result is that the depletion layer grows wider due to a lack of electrons and holes and presents a high impedance path, almost an insulator, and a high potential barrier is created across the junction, thus preventing current from flowing through the semiconductor material. Moving to the next slide. So now let's study about VI characteristics of a diode. This is the circuit diagram for forward bias. Meanwhile, this is the circuit diagram for reverse bias. Moving to the next slide. VI characteristics of diode. So this graph, we can see this is graph is for silicon. Yeah, for silicon as the peak knee voltage is 0.7 volt. We can see that in forward bias the graph increases as voltage current increases as voltage increases, and in reverse biased up to the breakdown voltage we see a very minute amount of current which is due to the minority charge carriers, whereas after the breakdown we see a huge amount of current which is due to the avalanche, which is known as peak which is known as avalanche current. This happens after we reach the breakdown voltage. Thank you.